How's it going, everybody? Welcome. My name is Zach Clement. I'm the principal engineer at WGU, and this is Jonathan Bone. He's our now staff engineer. We're both on the MLOps team at WGU. So for those that don't know, WGU is the largest university in the US. Online, we have approaching 190,000 students. So a pretty interesting opportunity to apply kind of large-scale ML and MLOps. So our presentation today is going to be MLOps at Western Governors University, Solutions to Production ML with Databricks. And first, just want to do an acknowledgement to all our team members. So thanks, guys, to Gabe, Jerry, Bart, who's the true mastermind of everything you're going to be seeing today, Camille, and Matt. Thanks a lot, guys. We're just here representing these people, so thanks to them. Okay, so quick overview of what we're going to be talking about today. I'll just go over a quick overview of the design phase, some of the challenges that we recognized before we started this project, then kind of the project goals that were distilled out of that. Then we'll talk about MARVIN, which is our MLOps platform, and the features and components of that. Then we'll briefly touch on the architecture and CICD processes, and then we'll jump into a demo. So Jonathan's going to be doing the demo. I'm going to be doing opening things up, which is kind of like a high-level overview of everything in the slides. So Jonathan has the hard demo aspect while I just get to read through some slides. And then after that, we'll leave time for some discussion. So we have 40 minutes. I'm going to try and run through these slides in 10 to 15 and leave like 20 minutes for the demo, and then 10 to 5 minutes for questions. Okay, so design phase. So we started this project back in March of 2023. And the first thing we did was we went and talked, the MLOps team went and talked to all the different people that were doing data science, machine learning at WGU, and talked to all these different groups and kind of distilled what we were hearing down into a few kind of key challenges. And so what this kind of turned out to be was a lack of governance and repeatability. There was no kind of established way of doing ML. Every team was kind of doing it their own way. There really wasn't any traceability or monitoring on the models that were being put into production. Nobody using MLflow, anything like that. And then really no automation. So everything was kind of deployed and built through the Databricks UI. Point and click, so if people were changing stuff, nobody really knew what was getting changed or who changed it or why they changed it. And then so we also saw this gap between like models being put into, POCs of models being developed and then the deployment process. Data scientists were generally doing the POCs and then they were kind of throwing it over the wall to data engineers to build out the workflows and put those into production. So kind of after distilling that, we kind of came up with this idea, started down the design process for what we call MARVIN. So MARVIN's our ML and now data ops platform. And the whole purpose of MARVIN is to put models into production. So we came up with this list of goals and then the features that kind of map to these goals. So we knew we wanted a self-governed and standardized data science environment. So the feature for that is like these automated creation of project level resources and permissions and access and things along those lines. We needed version control. Everything is code from the workflows, the computes, the compute configurations, permissions. No point and click, everything as code. And that kind of leads into things being auditable and lineage tracking. So using things like MLflow for being able to trace data and workflows and experiments, models, codes, permissions, everything that would be a part of an ML project, we want to be able to trace it from what's in production all the way back to this source. And then we wanted to simplify the production process, make it repeatable and standardized. So that's things like automation with CICD, and then these different dev stage and prod environments. So at WGU, we just have a single prod workspace, and so that kind of comes out to, that looks like folders for each environment. And then once the model's in production, we need to be able to maintain that model performance over time. So that's monitoring batch inference models, being able to compare candidate models against production models, providing tools for data validation and profiling, and then alerting for production models. So if anything breaks, we know that it's broken and we can fix it. And then finally, we knew we kind of had to balance the skill sets of our data scientists with what the MLOps needs were. So making things as simple as possible, using notebooks, widgets and workflows, things along those lines, tools that our data scientists were already using, so we're not asking them to completely change everything that they're doing. Okay, so kind of at a really high level, everything is kind of built on Databricks, and then obviously we're at the Databricks conference. So on top of that, everything, all our code is in GitHub, and all the CICD and that kind of side of the house is all in GitHub. So starting out with GitHub, we have a template repo, and so that template repo is used to instantiate new projects. So when a new project is started, our data scientists get a fresh new project repo, and we'll go into details of all this later. And then we have our projects manager repo, and so this is where we manage all our things like when we start a new project, there's pipelines in there to spin up all our new Databricks resources, and when we're updating projects in various ways, all that kind of flows through this projects manager repo. So that's on the GitHub side. On the Databricks side, we take those project repos, create a workspace repo in Databricks for our data scientists. Along with the project comes project compute and storage resources. There are workflows that are defined. And then we have the MLflow experiments and model registries associated with those projects. So just a few more details on some of these. So I touched on our projects manager repository. So this is where, like I said, we hold our project start and our project update. These kind of create and maintain Databricks assets. They create and maintain GitHub assets. They handle all the permissions associated with the project. And then we have like a bunch of tokens and service principals. And so we have workflows that kind of manage those tokens and service principals. And the template repository is basically it's based off of a copier template. And so that is instantiated into the new project. We have our user-facing Python package. So we give our users a Python package that helps them store all their data in a standardized place, and all their MLflow experiments and models and things like that. We give them some example code to kind of tee things up for them. We have and then we have the new project is instantiated with workflows for the CICD, and then we have our MK docs based documentation in there as well. And then just to touch on some of the open source tooling. Most of this is based on DBX, which has kind of been turned into Databricks asset bundles, I believe. But we're still based on DBX. It gives us a little bit more flexibility. MLflow, Delta tables, the Databricks SDK and CLI are super important here for creating all these Databricks assets. And then we use Evidently for our profiling, and Great Expectations for our data validation tooling. So I just wanted to include a kind of snapshot of our homepage of our documentation. We're super proud of our documentation. We spent a lot of time on it. On the left, you can see we have these user docs. We have our Python package documentation, and then our developer docs. Documentation takes time, and it's super important to do it right. So some security considerations. When we first started this project, we talked to security at WGU. It was really, on the GitHub side, it was really important to do things with the fine-grained token. So every new project gets added to this fine-grained token rather than giving them kind of like organizational permissions across, or they can like create new repos or destroy existing repos. So that's really important. And then we have Databricks admin tokens, which control the creation of all these Databricks assets. And so we put these behind a GitHub environment so that these actually require manual approval. So when we kick off a new project, we have this admin token that can do all this creation. And we have this behind environment, so just for an extra layer of security. All our automation is governed by Databricks service principals. And all the tokens that are associated with that are managed as well. And then on the Databricks side, all the permissions are group-based. So whenever a new project is created, we create a new group for that. We put people in those groups, and then we give permissions to the workspace, the experiments, the models, and the data through those groups. Okay. Quickly, I want to touch on the architecture. Jonathan's going to be doing a full walkthrough of this architecture. So I just want to go through this relatively quickly. So the three main kind of pipelines are our projects start. Once the project is started, we have a instantiated single project. And then once that project is going, people will want to update aspects of that. And that will be kind of like the Databricks piece of that. And then also, they might want to update like the Python package associated with that project. And that would be the template update. So this is the project start. So everything kind of starts in ServiceNow. So we give our users a ServiceNow form. They fill that out. And once that is approved, it automatically kicks off the pipeline, which goes through and kind of creates all these Databricks and GitHub assets. So we create a project group. We add the project participants that are defined by our users into that group. We create service principals. We link the service principal to GitHub, create project folders, create experiments, workflows, and models. We create compute and project schemas for that project. So now our users have a kind of like a shiny new project. And this is kind of like the architecture. This is really hard to see. It's kind of small and detailed, but the basic gist is we have CICD integration with these separate environments, dev, stage, and prod. They're all very similar. So we have orchestration tools with workflows. We capture all the experiments and models with MLflow. In production, we have batch inference, and we now have online inference with caching. And then we monitor those batch inferences. And all of this is kind of captured with the deploy code pattern. So I want to kind of talk through that CI/CD real quick. This is the diagram for it. Let me see how it looks. Those words are just capturing what I'm about to say. So when we start out, you're kind of on main. You have your fresh new repo. You create your dev branch. You run the changes on your dev branch using what we call our dev workflow executor. That creates your dev workflows, your model registry, and your experiments in dev. Once you're happy with how everything's looking in dev, you commit that code to your dev branch, and then you create a pull request. When you create that pull request, it kicks off. It goes into our staging environment, which basically kicks off our end-to-end test. So that creates all your stage artifacts, so your workflows, your model registry, and your experiments. Once you're happy with everything and everything's working well in stage, you merge that to main, and then that kicks off that puts things into production. And I don't want to go into too much detail here because we're kind of running out of time. And then finally, this is the project. Once you have your existing project, our users can update that project via their configuration files. So I'm not going to go into too much detail on this. Okay, so with that, I'm going to hand it over to Jonathan for the demo.
All right, so he mentioned the ServiceNow form. So ServiceNow refers to just an internal service we have where employees can go request things. So one of those is a MLOps project setup form. So this is where the data scientist starts interacting with the MLOps team. But ideally, before this, there's work that's been done in order to prepare for this. So we've put some prerequisites in place, things like they have to have a DAG, directed acyclic graph of their workflow. They have to have thought about cost. They have to have thought about who's going to participate in the project, these things. And so this is where they sort of compile all that information, and they're going to fill out things like, does your model perform regression, classifier or other? What's the MLflow flavor? A lot of these things are parameters for the template, the copier template that instantiates the repo. So they'll fill all this out, and they're going to click Order Now. And when they click Order Now, that stands up this data on an endpoint internally that we have, and it has a status. And that data is then sent through an approval process. Their manager approves it, our manager approves it. Once everything's approved, then we come over to the project manager repository. So the project manager repository has these workflows that we then take that data and then instantiate projects. So the first workflow that we run is called ServiceNow Puller. So this pulls the data off the endpoint, and then it stands up the necessary workflows that are going to be run to instantiate the project. And so the next workflow that's going to run is called Project Start. So when we run the ServiceNow puller, it's going to stand up a job that waits for approval, and that job is called project start. And the reason why we wait for approval from one of our team members is because there's, like Zach mentioned, there's a lot of admin tokens that are being used here, and so we don't want to just be standing up projects with admin tokens automatically. We have to, there has to be some manual approval process. And so we have this GitHub environment called project start admin approval. And this environment specifies that one of us can go in and approve this workflow, and then it'll run and instantiate the project. Okay, so once I've instantiated the project, I'm gonna come over here to this repository that I should have had up. Okay, so this repository is one that I've just run project start and instantiated with the copier template. So it says actions user, initial commit after scaffolding with copier. So it's run the project start workflow. It's taken our template repository. It's taken all the data that they put into that form, and it's created this repository that's parameterized to that specific project. So just want to walk through quickly some of these things. So the DBX folder is where we control our indirect environment separation. So it has all of the file paths that are important for the different environments. Our GitHub folder has all of the automation that this project is going to have. So specifically on the workflows, it has on-PR merge. So when they close a pull request, they merge it to main. There's configurations that could have changed relative to their compute. And so there's going to be an update that runs and matches what's in Databricks to what they have on main. The on pull request workflow, this is what runs their staging workflows. So when they create a pull request, it's going to run through DBX a workflow in Databricks, and then it's going to come back with the result. We have release triggers. So in that diagram, how we deploy to production is releasing off of GitHub, and those are controlled via release triggers, either via pre-release or release. And then we have this update template workflow that they can actually just come and run on dispatch, or one of us can run. And the reason why we do that is because our template repository is constantly changing. We're constantly adding new features, supporting new types of models, new types of monitoring techniques. And so they can come and run this workflow. It's going to dispatch the Lambda, and then it's going to come back with a pull request created for them. It's going to kick off the stage run with their code that's on main. It's going to run it through the stage environment. So there's a lot of automation that happens there just from then clicking this, and they can have access to new features. They can make code changes, et cetera. And then, so that's the automation side of things, but the data scientist isn't really going to be interacting with that very much. That's more, MLOps is focused on developing that. Where the data scientist is really going to work is the comp folder and the notebooks folder. So the comp folder has everything as code relative to their workflow. So it has model config, so all their models are going to be separate YAML files that have things like the MLflow flavor, the MLflow type. Have task configs, which are YAML files which can inject parameters into the task itself. So we have some different features that, like task skipping and things like that. We also have compute parameters. So this is where they can specify all of their different compute options, and they can specify it in the different environments. So they could have one type of compute in dev or stage and another type in prod. It's really helpful for, managing cost and controlling things on that side of things. But the data scientist, again, is mostly going to be in this file called project parameters. And project parameters is where they're going to specify their workflows. So they're going to take that DAG that they've developed, and they're going to represent that as just some task keys here. So this is just the instantiated templates. This is very basic. This is just, has these template files. You can add tags, email notifications. But the key point is I have two workflows already instantiated. I have IPTV, which stands for ingest, preprocess, train, validate. So that's the training workflow. And then I have BI, which stands for batch inference. That's their job that's likely going to be running more frequently. So they're gonna come in here, change things to what they want. And then another key component of project parameters is called project storage. So this is where they actually specify their tables. So this project storage section, they specify tables that they're going to be using in passing between different tasks. And there's some, they can specify if they want it to be an overwrite or if they want it to be an append. This is really helpful for running those batch inference jobs, and you have tables that you're writing to. You can do a lot of customization here. We also have an example project, which has a lot of code examples that they can pull from. And then we have the notebooks folder, which is where they're actually going to work in the dev environment and start putting their notebooks. So that's what I want to show more in detail. So I have this repository. It's just been templated. I'm going to come over to Databricks, and I've pulled it into my my repos. So this MLOps project start end-to-end test. So it's going to look like this. Everything I just went through is there. And like I said, they're going to be mostly working in the notebooks folder and the comp folder. So I've already gone ahead and developed the project parameters the way I want. So this is what this looks like after I've worked with this. So I've got a pre-process step. I've got a data profile step, data validation step. This is going to run dependent on pre-process. These are going to run in parallel. And then I've got this train model step that's going to follow data validation, data profile. So that's my IPTV. And then I've got my BI. And there's a pre-process inference. So the data is going to be ingested. And then the actual batch inference is going to run after that. So just a simple workflow. So I've got that set up. And then I'm going to come over to notebooks, pull my notebooks in. And I've already kind of hashed those out. And once I've pulled my notebooks in, then it's time to start working with this dev workflow tools like Zach mentioned. So there's two components of this that are really important for working in the dev environment. The first one is called config schema validator. So this is going to go through their comp folder over here, this comp folder, and it's going to validate all their YAML files are according to spec. So if this is successful, that means that the DBX is going to be able to take that code and set it up in a YAML file that works with that API. So I've run this. It says all my schemas are valid. If one of them's not, it will print out a message and show that it's not valid. And then once I've validated everything, I'm going to come down to the dev workflow executor. So there's three parameters of this object. So the get repository name, the project name, which can be different. In this case, they're the same. And then my workflow name. This workflow name needs to be a key that's in my project parameters as an actual workflow. So when I run this, I get this this DBX output, and that's not as important, but what is important is this link that comes out at the end. So I can click this link, and it'll take me to the actual workflow that ran. And I can see that this workflow was successful, and this is just in the dev environment. Okay, so that one's successful. So now I come back, and now I can run the BI workflow. So I just changed this parameter, this workflow name. I'm going to specify the BI key. I'm going to run this workflow. It's going to print out a link. I can click that, take me to the workflow, show me that it ran successfully. And so I can be sure that my code is in a good state to start staging it. So now that I've run those two steps, and one thing to call out here too is when we get these really long workflows, which we have dealt with, one thing that's really nice is this skip to task feature. So they can actually, assuming they've already previously run a few steps that they don't want to keep running every time they're iterating, they can actually skip downstream to a task, and it'll just pick that up and move along. So it really helps iterative development here. Okay, so now that I've got these workflows running in dev, it's time to stage my changes. So what I'm going to do is come up here. I've made a few changes to this branch. I'm going to say updated parameters. I'm going to commit and push. And I've already gone ahead and actually created the pull request off this demo branch, just to show you kind of a before and after without having to wait. So you'll notice that I just made this commit, and I've got these workflows that are running now. So it's got unit integration tests, and it's got some security scans and some other things. But this unit integration test is what's going to run my end-to-end test. It's going to deploy the workflows back to Databricks. So that you can see that running just based on that commit. And so scrolling back up here, just to show you how this process kind of unfolded. So the first commit I made, I see this red X here. This means that the end-to-end test actually failed. So as an MLOps engineer, I'd probably dig into this action output and try and figure out what actually happened that way. But as a data scientist, I don't really want to dig into that. So what we've done is created these comments. So after you've run a workflow, it'll actually output the status of each workflow. And so this one I can see failed, and so I can just click this link, and it'll take me to that workflow that ran in stage. And I can see that it failed. I can dig into it, and this one says there was something in my project parameters that wasn't right. And so I went ahead and fixed that, and then I recommitted, fixed task parameter, and then I can see this green check mark, and then I can also see the printout that those workflows were successful. So I can click these links, see these workflows, they were actually successful in dev, and that is true for both the IPTV and the BI. Okay, so now that I've had the workflows completed successfully, I'm actually gonna merge this branch. Ideally, I'd wait for all the workflows to run, but just for the sake of time, I'm gonna approve this and merge it to main. Okay, so now that I've merged it to main, like I mentioned, that update process kicks off. It actually goes out to the Lambda, tells it update the Databricks configurations based on what's on main, but it doesn't actually release to prod. So, like I said, the prod release happens on a release trigger. So I can come over here to releases, and I can create a new release. So I'm gonna choose a tag. I'm gonna say v1.0.0. I'm gonna generate release notes. And it's got these updates, and it shows my contribution there. And then I'm gonna set, yes, okay, so then I'm gonna publish this release. Okay, so I've got that release published, and then I can see that my release deployment triggers are now running. So these workflows are what's actually gonna take what I have on main, deploy them to production jobs in Databricks, and actually give me those workflows. And this, we might not have time to actually wait for this to update the job, but just to show you kind of a completed model that we have going currently. So this one was released using that workflow, and I can see the Git tag here in my in the jobs UI. And so I know that that corresponds to the release that that's the latest release on main. And then we have options for, you can run it on release, you can just update the definition on release, and add a schedule. There's a lot of customization around that, so that if they're constantly making changes, they don't necessarily want to be rerunning their training workflow frequently, so they can set that as just update definition and be done with it. Okay, so that's the sort of end-to-end workflow as a data scientist. A couple other things that I wanted to show real quick is the actual, just some of the code that we've developed for data scientists. So getting into the notebooks and into, just to point out a couple things, every notebook has this init object. So this init object actually does a lot behind the scenes. It takes their project parameters and it feeds them into this task. So when it's running in production, it has access to all the different parameters. So we've done models where we condition, which environment it's in. It'll do different things. It'll condense the data, maybe for stage. If we're doing a lot of stage runs, we don't want to be, using tons and tons of student data to slow that down. Maybe we want to just subset, or if we're using data across time. And then we've also got these storage functions. So we have this just save function, save df to table, takes a data frame, saves it to a delta table, and it does so in that indirect environment separation. So they don't have to worry about file paths or which environment path they're in. They can easily just save it, and then it's accessible by the workflow downstream. They can pick that table up, they can load it, there's a function for that. So an example of that is, I believe in train model. So they can load df from table, customer train clean, and then they can build the model. Another important feature that we have is this MLflow manager. This MLflow manager class is a wrapper around MLflow, and it greatly simplifies the syntax that they need to do to start and end runs. It associates all of the experiments with that indirect environment separation, has automatic model registration so that it automatically will appear in the model registry, and it has other features depending on if you're working with multiple models versus one model. There's also some automation there. We've got model comparer objects, we've got drift objects, data profiling objects, things that just make a lot of these monitoring capabilities really easy. So that's the demo.
Do you want to show quick MLflow artifacts?
Oh yeah. Let me show some So I can see that, so really quick, if I just look up this, this project that has a dev and stage and prod already, we have this, we have a dev experiment, we have a stage experiment, prod experiment. So every time they're running in that dev workflow tools, all their experiments are going to go into dev. Every time they're running on PR, it's going to go into stage. And every time they're running in production, it's going to go to prod. So we can come over here into dev and look at some of the runs. We work with nested runs. So every workflow that runs actually has its own experiment, and they can expand that, and they can see the different notebooks that ran, they can see the different models. It just makes it easier to organize a little bit. But we can come into this notebook and we can see, this one fit a model. We can see the different parameters, metrics, has full support for all this stuff that's already here. Okay, good. So some of the successes that we've had over the last year. So we took the timeline to migrate. The first POC that we did took about 2 months. There were a lot of bugs, a lot of things we hadn't thought through. We took that down to about 1 week. And that's comparing projects with similar complexity. Some of the projects we've taken on since have taken longer just because they're far more complex. But that's kind of the timeline reduction we've been able to put in place. And it's much more hands-on in data scientists, much more hands-off in the MLOps. In 6 months, we already maintain 11 production models. The goal was 5 for the first fiscal year. We have errors are caught very quickly with our Ops Genie integration. So we have one of us on call, and we have workflows that fail. Things are acknowledged very quickly and fixed. We've also been able to, I feel that we've been able to manage the collaboration between data science and MLOps fairly well. We have less separation between the data scientists and their actual production jobs. There's also a high amount of upskilling that's happening with the data scientists. They're getting much more familiar with GitHub, much more familiar with workflows, but they're also getting much more familiar with Databricks and all the features that has. And then along with that, we've also been able to kind of sell the idea that we can do a lot of stuff in-house versus third-party tools. Before MLOps, a lot of things at WGU were done with third-party tools. We've been able to bring a lot of things like, in-house, especially with LLMs and those types of projects that have been happening. And then we're currently dealing with a Unity catalog migration. We're planning to expand to data engineering and have their workflows be managed with the MLOps platform as well. And so another question, are we hiring? We currently have an open position for senior machine learning engineer and a senior research analyst. So the research analyst is probably a little less technical, but still potentially integrating with the MLOps team. And there's a lot more to come. We're a growing department within WGU. Like we said, we have a lot of students, a lot of opportunity for ML. So there's much more to come. And yeah, thanks.